Welcome to The Explainer. Today, we're going to tear open the storm clouds to really get a look at the incredible engineering that allows a massive aircraft like the C-17 to fly straight through what looks like pure, violent chaos.
You know that feeling, right? You're gripping the armrest, the plane drops and shakes, and it feels like the sky is just throwing these random punches. But what if I told you it's not random at all? And this, right here, is the key. This is the critical shift in thinking. What feels like this random, violent shaking is actually a set of predictable, totally measurable physical forces. And, well, once you can measure a force, you can engineer a solution to beat it. So, to understand how an aircraft can possibly survive this, we first have to understand exactly how the atmosphere attacks. And trust me, it's not just bumpy air. It is a battleground of invisible, powerful energy. Okay, so first things first, forget the idea of bumpy air. Instead, I want you to picture the sky as this violent, three-dimensional ocean. It's got powerful currents, it's got waves that can crash, and these whirlpools of energy, these vortices that can literally grab an aircraft. And what's so fascinating is that each type of bump you feel is a totally distinct physical event. You've got convective turbulence, which punches the plane up and down. Then you have mechanical turbulence, which is basically the air tripping over mountains and buildings. Each one of these is a different kind of problem for engineers to solve. And this slide just nails it. This is the mental shift we all need to make. We are moving away from this feeling of being a helpless victim of random chaos, and we're moving toward understanding a solvable physics problem. It's not just bumps, it's force vectors.
So, every single jolt you feel has a name and a direction. That sudden drop, that's vertical G-loading. That sideways slam you feel, that's lateral shear. So you see, pilots and engineers, they're not fighting some random shaking. They are actively countering measurable forces that are trying to push, pull, and twist the aircraft.
All right, now that we know the enemy, let's meet the champion that was built to fight it, the C-17 Globemaster. This isn't just any aircraft. This thing was designed from the ground up to fly into the world's absolute harshest conditions and win. The C-17's first, and maybe its most obvious, line of defense is just its incredible mass. We're talking over 500,000 pounds. It has so much inertia, it acts like a giant, stabilizing anchor in that chaotic, invisible ocean of air. You know, it's really just basic physics. A heavier object is simply harder to push around. This high inertia lets the C-17 power through gusts of wind that would just violently throw a smaller plane off course. It literally smooths out the ride. But sheer mass isn't the whole story, not even close. This quote right here perfectly captures the philosophy behind the C-17's second huge advantage, its incredible structural flexibility. This plane isn't designed to be a rigid brick, it's designed to be a resilient athlete. And that brings us to this crucial concept called aeroelasticity. Think of it like a dance between the air trying to bend the plane and the plane's own structure bending in response. Now, managing this dance is absolutely the key to survival, because if it goes wrong, the results can be catastrophic. If it's uncontrolled, this dance can spiral into a deadly chain reaction. The airflow separates from the wing, which causes this violent shaking called buffeting. That can then escalate into something called flutter, a destructive vibration that can literally tear a wing apart. The C-17 is engineered to make sure that never, ever happens.
And here is how it does it. Look at this list. Every single component is just over-engineered. The wing spars are made to flex and absorb energy. It has not one, not two, but 3 redundant hydraulic systems. Even the joints are built to resist fatigue from thousands and thousands of stress cycles. This thing isn't just a plane, it's a fortress with wings.
But just when you think this airframe is completely invincible, turbulence reveals a much more insidious danger. See, it's not just about shaking the plane apart, it's about what it does to the engines.
So here's the problem. A modern jet engine is an incredibly precise instrument. It absolutely needs a smooth, stable flow of air to generate thrust, and violent turbulence is the exact opposite of that.
Think of the engines as the aircraft's lungs. A storm is actively trying to choke them. It feeds them chaotic, turbulent air, which can cause a compressor stall. It can throw massive amounts of water, slush, or ice right into them, all of which can starve the engine of air and power right when the pilot needs it the most. Okay, so the airframe is flexing, the engines are under assault, so what about the human at the controls? I mean, how does a pilot even begin to manage this high-stakes, incredibly high-stress environment?
Well, flying through a severe storm is just an intense mental challenge. The pilot is in this constant loop, scanning instruments, making tiny power adjustments to keep the engines happy, and maintaining total awareness of where the plane is going, all while being physically shaken around. It's as much a mental battle as it is a mechanical one.
So, with all of this in mind, the physics, the engineering, the human factor, let's go back and re-examine those really dramatic videos you see online of planes landing in storms.
What's really cool is how this breaks down the illusion. What looks like this terrifying out-of-control movement on camera, it's often just the effect of a telephoto lens and a bouncing camera mount. In reality, the aircraft's flight path is way more stable, and those flexing wings you see, they're doing exactly what they were designed to do, absorb the storm's energy.
And once you understand the science behind it, your whole perspective just shifts. You're no longer watching a machine barely surviving by luck. You are watching a finely tuned system performing exactly as it was designed to. A powerful testament to decades of brilliant engineering.
And that is the ultimate takeaway here. Storms are not magic. They aren't just random chaos. They are just a very, very complex set of physics problems. And the C-17 is the elegant, powerful, and ridiculously overbuilt solution that was engineered to win that fight every single time. It really makes you wonder, doesn't it? What other huge challenges out there that seem chaotic and just insurmountable are really just waiting for the right engineering mindset to solve them? Thanks for watching.